The submerged stone structures discovered off the coast of Yonaguni, Japan, in 1986 present one of the most compelling challenges to conventional timelines of human civilization. Marine geologist Masaki Kimura spent over 15 years documenting these underwater formations, which extend across an area of approximately 60 by 50 meters and reach depths of 25 meters below current sea level. The structures display geometric precision that conventional geology struggles to explain through natural processes, featuring right angles, straight edges, parallel surfaces, stepped pyramids, and what appear to be ceremonial platforms carved from solid bedrock. The dating of these monuments, based on when the area was last above sea level, places their construction between 12,000 and 10,000 years ago, predating the earliest known civilizations in Mesopotamia by over 6,000 years. What makes the Yonaguni discovery particularly significant is not its isolation, but rather how it fits within a global pattern of underwater archaeological sites that consistently predate known civilizations. Off the coast of Gujarat, India, marine surveys have documented the submerged city of Dwarka at depths of up to 40 meters, matching descriptions in Hindu texts of Krishna's capital that supposedly sank beneath the waves. In the Mediterranean, the ancient port of Pavlopetri lies preserved beneath Greek waters, its streets and buildings arranged in sophisticated urban planning that dates to at least 5,000 years ago, though some elements may be significantly older. These discoveries share common characteristics: advanced construction techniques, urban planning sophistication, and submersion dates that correspond to the massive sea level rises following the last ice age. The implications become even more profound when we examine the chronological convergence. Geological evidence demonstrates that global sea levels rose approximately 120 meters between 15,000 and 7,000 years ago as the ice sheets melted. This inundation would have submerged vast areas of continental shelf that during the Ice Age formed fertile coastal plains ideal for human settlement. The Persian Gulf was completely exposed during the glacial maximum, creating an extensive river valley fed by the Tigris, Euphrates, Keren, and other regional rivers. The Sunda Shelf connecting Indonesia, Malaysia, and Thailand formed a landmass covering over 1.8 million square kilometers. Beringia linked Asia and North America across an area larger than modern Alaska. If advanced civilizations developed in these now submerged regions, their remains lie beneath hundreds of feet of water, invisible to conventional archaeology that focuses exclusively on sites accessible on modern land surfaces. The evidence we are about to examine suggests that what we call the first civilizations in Mesopotamia, Egypt, and the Indus Valley may actually represent survivor cultures, rebuilt by refugees from older civilizations destroyed by the post-glacial flooding. The sudden appearance of sophisticated urban planning, advanced mathematics, precise astronomy, and complex writing systems in these locations around 3500 BC begins to make sense not as spontaneous invention, but as reconstruction, using preserved knowledge from earlier sources. This investigation will trace the archaeological evidence for these predecessor civilizations, examine how their knowledge was preserved through catastrophic flooding, and document the systematic rebuilding that created what conventional history mistakes for humanity's first complex societies. The systematic mapping of underwater archaeological sites over the past 4 decades has revealed a striking pattern that conventional archaeology struggles to address. Marine surveys using side-scan sonar, multi-beam bathymetry, and remotely operated vehicles have documented over 200 substantial underwater structures across all major ocean basins, concentrated particularly along continental shelf regions that were exposed during the last glacial maximum. The Japan Agency for Marine Earth Science and Technology conducted extensive surveys between 1998 and 2007 that identified over 30 distinct underwater structural complexes around the Japanese archipelago alone, each displaying characteristics consistent with artificial construction rather than natural geological formation. The Yonaguni Monument represents the most extensively studied of these Japanese underwater sites. Professor Masaki Kimura from the University of the Ryukyus conducted over 500 dives to document the structure between 1996 and 2011, measuring and photographing every accessible surface of the formation. The structure displays parallel walls, right-angle corners, and flat surfaces spanning areas of 15 to 20 meters that maintain consistent orientations and geometric relationships throughout the complex. tool marks visible on certain stone surfaces show evidence of cutting and carving techniques, while the overall layout suggests deliberate architectural planning with ceremonial chambers, staircases, and corridor systems arranged in patterns unlikely to occur through natural erosion processes. The underwater city of Dwarka off the coast of Gujarat, India, provides even more conclusive evidence of submerged habitation sites. Marine archaeological surveys conducted by teams from the National Institute of Oceanography between 1983 and 2005 documented extensive ruins extending over several square kilometres of seafloor, at depths ranging from 10 to 40 metres. The site contains massive stone blocks fitted together with precision joinery, architectural elements including walls, gates, and what appear to be harbour facilities, and pottery fragments that match descriptions in the Mahabharata of Krishna's legendary capital. Carbon dating of wooden artefacts recovered from the site produced dates ranging from 7,500 to 3,500 years ago, establishing that substantial urban development existed in this now submerged area during periods when conventional history places only primitive settlements in the region. Pavlopetri off the southern coast of Greece represents the oldest submerged city yet discovered in the Mediterranean. Identified initially by Nicholas Fleming in 1967 and comprehensively mapped by teams from the University of Nottingham between 2009 and 2011, the site covers approximately 50,000 square metres and contains the remains of at least 15 separate buildings arranged along streets in a planned grid pattern. The urban layout includes a sophisticated water management system with channels, basins, and what appear to be fountains or ritual pools. Ceramic evidence dates the site's occupation to at least 5,000 years ago, though some architectural elements may be significantly older, based on their construction techniques and the degree of marine erosion observed on certain structures. These discoveries share common characteristics that distinguish them from typical underwater archaeological sites, formed by gradual coastal subsidence or localized geological events. The structures demonstrate urban planning principles, including organized street layouts, public spaces, residential districts, and specialized functional areas for commerce, worship, or administration. The construction techniques involve megalithic stonework, precision fitting of large blocks, and engineering solutions for water management and structural stability that require advanced technical knowledge. Most significantly, the depth and location of these sites correspond to sea level positions that occurred during the late glacial and early post-glacial periods, placing their construction and habitation during timeframes that conventional chronology considers pre-civilizational. The precise chronology of post-glacial sea level rise provides crucial context for understanding when underwater sites were last habitable. Ice core data from Greenland and Antarctica, analysed by teams from the University of Copenhagen and the British Antarctic Survey, reveals that sea level rise occurred in distinct phases rather than as a gradual process. The most dramatic rise happened between 14,800 and 14,300 years ago, when global sea levels increased by approximately 20 metres within just 5 centuries. This event, marking the termination of the Younger Dryas cold period, would have inundated coastal settlements with remarkable speed, giving inhabitants little time to evacuate or preserve infrastructure. The Greenland Ice Core Project and the European Project for Ice Coring in Antarctica produced complementary datasets that reveal the precise timing and magnitude of post-glacial warming. Ice cores extracted from depths exceeding 3,000 metres contain annual layers of accumulated snowfall that preserve atmospheric composition, temperature proxies, and volcanic ash markers spanning over 100,000 years of climate history. Analysis of oxygen isotope ratios in these ice layers provides temperature reconstructions, showing that the Younger Dryas cold period ended abruptly approximately 11,700 years ago, with temperatures in Greenland rising by approximately 10 degrees Celsius within a single decade. This rapid warming triggered massive ice sheet collapse and accelerated melting that produced catastrophic sea level rise. Coral reef terraces preserved at various depths around tropical islands provide direct evidence of past sea level positions, allowing reconstruction of the precise chronology of ocean level changes. Studies of these reef terraces by teams from the Australian National University and the University of Oxford demonstrate that sea level rise occurred in pulses rather than steadily, with periods of rapid increase separated by intervals of relative stability. The most significant pulse, termed Meltwater Pulse 1A, occurred approximately 14,600 years ago and raised global sea levels by between 14 and 18 meters within approximately 340 years. The implications for coastal human populations during this period become clear when we model the geographical extent of the inundation. Computer simulations based on bathymetric data and ice sheet models show that this sea level rise would have submerged approximately 25 million square kilometers of previously habitable land, including the most productive coastal plains and river deltas, where archaeological evidence suggests early human populations concentrated. The Persian Gulf, currently averaging only 35 meters in depth, was completely dry land during the glacial maximum, forming an extensive valley fed by major river systems that created ideal conditions for human settlement. This entire region would have been inundated within a few centuries as sea levels rose, displacing any populations that had developed there and destroying surface evidence of their occupation. The Sunda Shelf in Southeast Asia presents an even more dramatic example of lost land. During the glacial maximum, sea levels approximately 120 meters below present levels exposed a landmass connecting the Malay Peninsula, Sumatra, Java, and Borneo in a continuous territory larger than the Indian subcontinent. This region, termed Sunderland by geologists, included major river systems, extensive forests, and diverse ecosystems that would have supported large human populations. The gradual flooding of Sunderland between 15,000 and 7,000 years ago would have forced massive population movements, creating refugee migrations that could explain the sudden appearance of advanced agricultural and architectural techniques in regions surrounding the former landmass. Archaeological evidence from sites on current land surfaces adjacent to these drowned regions shows sudden increases in population, technological sophistication, and cultural complexity during the immediate post-glacial period, consistent with the arrival of displaced populations carrying advanced knowledge from flooded homelands. The cave paintings of Sulawesi, recently dated to at least 44,000 years ago using uranium-thorium dating of calcite deposits, demonstrate that sophisticated artistic traditions existed in the Sunderland region long before the flooding. The sudden appearance of similar artistic styles, agricultural techniques, and architectural principles in mainland Southeast Asia, southern China, and the Pacific Islands during the early Holocene suggests knowledge transmission from the flooding Sunderland populations. The megalithic temple complex at Göbekli Tepe in southeastern Turkey completely overturns conventional models of civilizational development by demonstrating that monumental architecture preceded agriculture rather than following it. Excavations directed by Klaus Schmidt beginning in 1995 uncovered massive T-shaped limestone pillars, some weighing over 20 tons, arranged in circular formations and decorated with sophisticated bas-relief carvings of animals, anthropomorphic figures, and abstract symbols. Radiocarbon dating of organic materials found in the construction places the earliest phases of construction at approximately 9,600 BC, making Göbekli Tepe 6,000 years older than Stonehenge and contemporary with the end of the last ice age. The site consists of at least 20 circular and oval structures, though only a fraction have been excavated since the site covers approximately 22 acres of hilltop terrain. Each structure centers on pairs of T-shaped pillars standing 3 to 5 meters tall and weighing between 10 and 20 tons. These central pillars are surrounded by smaller pillars arranged in circles, with stone walls connecting them to form enclosed spaces. The pillars display sophisticated carving techniques including three-dimensional sculpture, bas-relief images, and abstract geometric patterns that demonstrate advanced artistic capabilities and symbolic thinking. The animal carvings include precise anatomical details identifying specific species: lions, bulls, wild boars, foxes, snakes, vultures, and numerous bird species, all rendered with naturalistic accuracy that indicates close observation and artistic skill. The anthropomorphic figures display human characteristics combined with animal attributes, suggesting complex mythological or religious concepts. Some pillars feature abstract symbols including H-shaped glyphs, crescents, and circular patterns whose meanings remain undeciphered, but clearly represent a sophisticated symbolic system. The construction techniques required to create Göbekli Tepe exceeded the capabilities typically attributed to hunter-gatherer societies. The limestone pillars were quarried from bedrock located approximately 500 meters from the construction site, requiring coordinated labour to extract, shape, transport, and erect stones weighing up to 20 tons without metal tools or wheeled vehicles. The precision of the carving and the consistency of the T-shaped pillar design across multiple structures indicate standardized planning and specialized craftsmen working from established architectural principles rather than experimental building techniques. Most significantly, the site shows no evidence of permanent habitation. Excavations have revealed no domestic structures, cooking facilities, or residential refuse typical of settled communities. Instead, the archaeological evidence suggests Göbekli Tepe functioned as a ceremonial centre that attracted periodic gatherings of people who lived elsewhere, requiring organisational capabilities and social structures typically associated with later agricultural civilizations. The absence of domesticated plant or animal remains contemporary with the earliest construction phases indicates the builders were still practicing hunting and gathering subsistence strategies, contradicting the conventional sequence placing agriculture before monumental architecture. The deliberate burial of Göbekli Tepe around 8000 BC presents another puzzle that conventional explanations struggle to address. Rather than abandoning the site to natural decay, the inhabitants systematically filled the structures with debris, carefully covering the carved pillars and preserving them intact. This intentional burial suggests conscious preservation for future discovery, raising questions about what knowledge the builders intended to protect and why they believed burial would achieve this preservation better than continued maintenance. The archaeological sites of the Ubaid period in Mesopotamia, dating from approximately 5800 to 4000 BC, demonstrate levels of technological and organizational sophistication that challenge the narrative of gradual development from primitive settlements. Excavations at Tel Es-Sarwan, conducted by Iraqi archaeologist Fouad Safar between 1964 and 1968, uncovered a settlement featuring sophisticated irrigation systems, standardized pottery production, and architectural layouts displaying advanced planning principles. The site's location in central Iraq, far from the later Sumerian heartland in the south, suggests that the technological foundations of Mesopotamian civilization developed in a broader geographical area than traditionally recognized. The irrigation systems at Tel Es-Sarwan demonstrate engineering knowledge that required understanding of hydraulic principles, surveying techniques, and coordinated labor organization. The excavations revealed channels carved through bedrock using tools capable of cutting precise gradients necessary for optimal water flow. These channels extended over several kilometers, connecting the settlement to distant water sources and distributing irrigation water to agricultural fields through a network of smaller distribution channels. The engineering calculations required to design this system, accounting for elevation changes, flow rates, and seasonal variation in water availability, indicate access to sophisticated mathematical and hydraulic knowledge. The pottery production at Tel Es-Sarwan shows evidence of standardization and quality control that indicates specialized manufacturing beyond household craft production. The ceramics display uniform wall thicknesses, consistent firing temperatures, and decorative patterns applied with precision, suggesting the use of templates or measuring devices. Chemical analysis of pottery sherds from Tel Es-Sarwan and other Ubaid sites reveals that ceramics were produced from carefully prepared clay mixtures with controlled ratios of tempering materials, indicating understanding of material science principles necessary for optimizing ceramic properties. The architectural layouts at Ubaid sites display planning principles including standardized building dimensions, oriented street grids, and specialized functional areas for different activities. Buildings at Tel Es-Sarwan were constructed using mud bricks of uniform dimensions, produced in standardized molds, creating modular construction systems that allowed efficient building and enabled architectural consistency across the settlement. The organization of domestic storage and ceremonial structures follows patterns suggesting centralized planning rather than organic growth, indicating administrative capabilities for coordinating community development. The broader Ubaid culture extended across Mesopotamia from the Persian Gulf to northern Syria, encompassing hundreds of settlements that shared ceramic styles, architectural principles, and technological practices. This cultural uniformity across such a vast geographical area suggests communication networks, trade systems, and possibly administrative coordination that required organizational capabilities typically associated with later state-level societies. The Ubaid expansion into previously unsettled regions of southern Mesopotamia involved large-scale environmental engineering including marsh drainage, canal construction, and soil management that transformed marginal wetlands into productive agricultural territories. The transition from Ubaid to early Sumerian civilization shows continuity in many technological and organizational practices, suggesting that Sumerian achievements built upon established Ubaid foundations rather than representing entirely new developments. However, the speed and scale of advancement during the transition period raises questions about whether this continuity fully explains the sophistication of Sumerian civilization or whether additional knowledge sources contributed to the rapid development. The archaeological record of Sumerian emergence presents what scholars term a discontinuity problem, the absence of clear developmental stages leading to the sophisticated civilization that appeared around 3500 BC. The earliest Sumerian cities, including Uruk, Eridu, and Nippur, display from their founding layers urban planning principles, architectural techniques, and administrative systems that show no evidence of gradual evolution from simpler predecessors. German Archaeological Institute excavations at Uruk have documented that even the earliest building levels, dating to approximately 3200 BC, contained multi-story structures, complex drainage systems, and standardized brick production methods that appear fully developed rather than experimental or crude. The city of Uruk covered approximately 600 hectares at its peak, making it the largest urban center in the world during the 4th millennium BC with an estimated population of 40,000 to 80,000 inhabitants. The urban layout included distinct residential, commercial, religious, and administrative districts organized along planned street networks. The temple precincts featured massive platforms supporting monumental architecture, including the White Temple and the Anu Ziggurat, structures requiring sophisticated engineering for foundation stability, materials transport, and construction coordination. The administrative systems evidenced at early Sumerian sites display bureaucratic sophistication, including hierarchical organization, specialized personnel, standardized record-keeping, and complex economic management. The earliest cuneiform tablets from Uruk, dating to approximately 3400 BC, record economic transactions using numerical notation systems, commodity designations, and accounting procedures that demonstrate established administrative protocols rather than experimental record-keeping. These tablets show knowledge of mathematics, including place value notation, fractional calculations, and area measurements used for land surveying and resource allocation. The sudden appearance of writing itself represents one of the most dramatic discontinuities in the Sumerian record. While some scholars identify proto-writing symbols in earlier contexts, the cuneiform system that emerged at Uruk around 3400 BC was a complete writing system capable of recording complex information, including numerical data, commodity inventories, legal contracts, and eventually literary and religious texts. The rapid development of this system, evolving from simple pictographs to abstract phonetic symbols within a few centuries, suggests either remarkably rapid innovation or the revival of writing knowledge from earlier sources. The metallurgical capabilities demonstrated in early Sumerian artifacts exceed what conventional models predict for a recently urbanized society. Bronze working, requiring knowledge of ore sources, smelting temperatures, and optimal alloy ratios, appears in the earliest Sumerian layers without evidence of experimental phases or gradual refinement. The quality of bronze tools and weapons from early Sumerian contexts matches that of much later periods, indicating that metallurgical knowledge was inherited rather than discovered through trial and error. The sources of copper and tin used in Sumerian bronze production included distant regions in Anatolia, Iran, and possibly Central Asia, requiring extensive trade networks and geographical knowledge that developed remarkably quickly after urbanization. The astronomical knowledge evidenced in Sumerian texts and architectural alignments demonstrates understanding of celestial mechanics that required centuries of systematic observation and mathematical analysis. The Sumerians tracked the movements of planets, calculated lunar cycles with precision sufficient for calendar maintenance, and identified constellations used for navigation and timekeeping. This astronomical knowledge appeared in Mesopotamia as a fully developed system, without evidence of the observational records and calculation refinements that such knowledge would require if developed locally from scratch, suggesting it was inherited from earlier astronomical traditions. The administrative tablets from Nippur, Uruk, and Eridu contain detailed descriptions of a governing structure that modern scholars interpret as mythology, but which the Sumerians themselves presented as historical administration. Tablet CBS 10,673 describes the division of territorial authority among three primary divine administrators: Anu governing the northern regions and upper atmosphere, Enlil controlling the central plains and weather systems, and Enki managing the southern marshlands and subterranean waters. The document specifies geographical boundaries using precise distance measurements and landmark identifications, suggesting these divisions represented actual administrative territories rather than abstract cosmic domains. The tablet employs the same formulaic administrative language found in mundane economic records from Sumerian temple archives, using standard terminology for territorial boundaries, resource allocation, and jurisdictional authority. The text describes Anu's domain as extending from the mountains of the north to the place where the great rivers converge, providing geographical markers that correspond to specific locations in Upper Mesopotamia and southern Anatolia. The boundaries are measured in units called dana, approximately equivalent to 10.8 kilometers, with distances specified between named landmarks that can be correlated with actual geographical features. Enlil's central domain encompassed the most productive agricultural regions of Mesopotamia, described in the tablet as the land between the rivers, where the grain grows tall and the waters are sweet. The administrative responsibilities assigned to Enlil in these texts focus on weather control, agricultural productivity, and water management, domains that would be essential for governing the civilization's economic foundation. The precision with which these responsibilities are delineated suggests functional administrative divisions rather than purely symbolic religious concepts. Enki's southern territory included the marshlands near the Persian Gulf and the subterranean freshwater aquifer that the Sumerians called the Abzu. The tablet describes Enki's authority over underground waters, mineral resources, and what the text terms the shaping of the clay people, a reference that appears in multiple contexts related to human creation and genetic modification. The administrative language describes oversight of mining operations, metallurgical facilities, and specialized production centers located within Enki's territorial jurisdiction. Supporting tablets from the same archive complex provide additional details about the administrative infrastructure supporting this territorial division. Document VAT 17,019 describes a council structure where the three primary administrators convene to resolve jurisdictional disputes, coordinate resource sharing, and establish policies affecting multiple territories. The text indicates that these council sessions followed formal protocols including agenda setting, presentation of data regarding resource levels and population conditions, deliberation among council members, and formal recording of decisions in tablets that were distributed to administrative centers throughout the system. The Sumerian king list, preserved in multiple copies including the Well-Blundell Prism in the Ashmolean Museum, provides chronological context for this administrative system by recording the rulers who governed before and after the Great Flood. The list divides rulers into two categories: antediluvian kings who ruled for extraordinarily long periods, measured in tens of thousands of years, and post-diluvian rulers with more comprehensible reign lengths, though still exceeding normal human lifespans. The antediluvian section describes 8 kings ruling 5 cities over a combined period of 241,200 years, while the post-diluvian section shows dramatically shorter reigns beginning with Kish and continuing through the historical Sumerian dynasties. The precision with which these reign lengths are recorded, including exact numbers rather than round figures, suggests the compilers were working from actual chronological records rather than inventing mythological numbers. The mathematical relationships between the recorded reign lengths reveal sophisticated patterns, with many figures representing multiples of a base unit of 3,600 years called a sar in Sumerian. This numerical precision implies the use of specific temporal measurement systems tied to astronomical cycles rather than arbitrary mythological invention. Administrative texts from Lagash and Umma describe ongoing jurisdictional disputes over water rights and territorial boundaries that reference the original divisions established by the divine administrators. These disputes, documented in tablets dating from the 24th century BC, cite precedents from the time of the gods as legal justification for territorial claims. The texts indicate that the administrative divisions attributed to Anu, Enlil, and Enki continued to structure political and legal relationships among Sumerian city-states centuries after the supposed departure of divine rule, suggesting these divisions reflected actual historical arrangements rather than purely religious mythology. Egyptian historical records preserved in the Turin King List and the writings of Manetho describe a primordial period called Zep Tepi, the first time, when divine beings established the foundations of Egyptian civilization before the first human dynasties. The Turin Papyrus, discovered by Italian explorer Bernardino Drovetti in 1822, lists the reigns of divine rulers including Ptah, Ra, Shu, Geb, Osiris, Seth, and Horus, each credited with introducing specific technologies and governing for periods measured in thousands of years. Manetho's Egyptiaca, composed during the 3rd century BC while serving as high priest at Heliopolis, provides additional details describing these divine rulers as beings who possessed knowledge of astronomy, mathematics, and engineering that far exceeded human capabilities of the period. The Turin Papyrus, though fragmentary and damaged, preserves crucial chronological information that correlates with architectural and astronomical evidence from pre-dynastic Egypt. The papyrus indicates that Ptah's reign lasted 9,000 years, during which he established the principles of architecture and metallurgy that would characterize later Egyptian construction. The text describes Ptah as the master craftsman who opened the mouths of the gods, a reference to activation or initialization procedures that suggest technological rather than purely spiritual functions. Ra's recorded reign of 1,000 years corresponds to the solar symbolism that dominates Egyptian religious architecture and astronomical observations. Manetho's account describes Ra as establishing the calendar system based on the heliacal rising of Sirius, the astronomical event that marked the beginning of the Egyptian year and the annual flooding of the Nile. The precision required to develop this calendar demonstrates sophisticated astronomical observation capabilities and mathematical calculations that correlate celestial events with terrestrial seasonal cycles. The Palermo stone, a basalt stele dating to the 5th dynasty, but recording events from pre-dynastic times, provides additional chronological data that supports the Turin Papyrus framework. The stone lists rulers designated as followers of Horus, who governed Egypt during the transitional period between divine rule and the first human dynasties. These transitional rulers are credited with consolidating the administrative systems, architectural principles, and religious practices that would continue throughout pharaonic civilization. The stone's chronology places these transitional rulers approximately 5,000 years before the first dynasty, suggesting that sophisticated governmental structures existed in Egypt far earlier than conventional chronology acknowledges. Archaeological evidence from Hierakonpolis, located in Upper Egypt near modern Edfu, provides physical confirmation of advanced pre-dynastic capabilities. Excavations conducted by James Quibel and Frederick Green between 1897 and 1899 uncovered artifacts demonstrating sophisticated metallurgy, astronomical knowledge, and hydraulic engineering predating the first dynasty by several centuries. The Hierakonpolis painted tomb, designated Tomb 100, contains wall paintings depicting figures with characteristics matching Mesopotamian descriptions of the Anunnaki, suggesting cultural contact or common origins between pre-dynastic Egyptian and Mesopotamian civilizations. The Edfu building texts, inscribed on the walls of the Temple of Horus at Edfu during the Ptolemaic period, but clearly based on much earlier sources, describe the reconstruction of sacred sites according to ancient plans preserved from the first time. These texts reference builder texts documenting construction techniques and astronomical knowledge used by the original divine inhabitants of Egypt. The inscriptions describe sacred mounds where original knowledge was preserved in underground chambers containing scrolls and artifacts from the previous civilization, sealed to protect their contents from future catastrophes. The consistency between Egyptian and Mesopotamian accounts of divine administration suggests either direct contact between these civilizations during their formative periods, or derivation from common antecedent sources. Both traditions describe territorial divisions among divine administrators, technological knowledge transferred to human populations, and administrative systems that structured civilization development. The chronological frameworks in both traditions place these events in the period following catastrophic flooding, supporting interpretations that link these accounts to actual historical events during the post-glacial period. The construction precision demonstrated at the Giza Pyramid complex exceeds the documented capabilities of ancient Egyptian technology by substantial margins, suggesting access to more advanced methods than conventional Egyptology acknowledges. The Great Pyramid's foundation platform achieves levelness to within 2.1 centimeters across its 230-meter base, a tolerance that requires surveying capabilities and construction techniques approaching modern engineering standards. The casing stones, originally covering the pyramid's exterior, were fitted together with joints of approximately 0.5 millimeters, creating surfaces so smooth that even modern stonemasons struggle to replicate the precision using contemporary tools. The surveying precision required to achieve this foundation levelness demands instruments and techniques capable of measuring elevation differences of millimeters across distances of hundreds of meters. Modern laser surveying equipment can achieve such precision, but the copper tools and wooden measuring rods conventionally attributed to ancient Egyptian builders cannot account for the observed accuracy. The foundation platform was carved from the natural bedrock and supplemented with precisely cut limestone blocks to create a level surface, requiring removal of irregular rock formations and filling of depressions with measured precision across the entire pyramid base. The core masonry of the Great Pyramid consists of approximately 2.3 million limestone blocks, weighing between 2 and 15 tons each, with some granite blocks in the King's Chamber weighing up to 80 tons. The precision with which these blocks are fitted together creates a structure of remarkable stability that has withstood earthquakes, weathering, and human intervention for over 4,500 years. Analysis of the core masonry reveals that blocks were positioned with minimal mortar, relying primarily on precise fitting and gravitational forces to maintain structural integrity. The casing stones presented even greater challenges requiring precision cutting, transportation, and positioning of limestone blocks finished to optical smoothness. Petri's survey of remaining casing stones in 1881 documented joint tolerances averaging 0.5 millimeters, with some joints achieving even tighter fits. The outer surface of these casing stones was polished to create a smooth, brilliant white appearance that would have made the completed pyramid visible from great distances. The removal of most casing stones during medieval times prevents complete analysis, but remaining examples at the pyramid's base demonstrate the extraordinary precision of the original construction. The internal chambers and passages display similar precision in different contexts. The Grand Gallery, ascending at a 26-degree angle toward the King's Chamber, maintains precise dimensional tolerances over its 46-meter length. The corbelled ceiling rises 8.6 meters using overlapping limestone blocks that create a structurally sound vault without the need for a keystone. The engineering calculations required to design this corbelling system, accounting for load distribution and structural stability, demonstrate sophisticated understanding of architectural principles. The King's Chamber presents particular engineering challenges that ancient builders solved with remarkable sophistication. The chamber measures 10.5 meters east to west, 5.2 meters north to south, and 5.8 meters in height, dimensions that encode mathematical relationships including the golden ratio. The granite blocks forming the chamber walls weigh up to 80 tons each and are fitted together with precision joints, despite the extreme weight and hardness of the material. Above the King's Chamber, 5 relieving chambers distribute the weight of the overlying masonry, preventing collapse of the chamber ceiling under the enormous gravitational load. The precision of the Great Pyramid extends to its astronomical and geographical alignments. The structure is aligned to true north with an accuracy of 3 arc minutes, a precision that requires sophisticated astronomical observation and surveying techniques. The pyramid's base perimeter of 921.5 meters divided by twice its height of 146.6 meters yields a value of 3.143, approximating pi to 3 decimal places. This mathematical relationship appears too precise to be coincidental, suggesting the pyramid's designers encoded mathematical constants in the structure's proportions. The astronomical alignments incorporated into ancient monuments worldwide demonstrate knowledge of precessional cycles that require centuries of continuous observation to detect and sophisticated mathematics to calculate. The phenomenon of precession, caused by Earth's axial wobble, creates a cycle lasting 25,920 years, during which the position of the celestial poles and the zodiacal constellation visible during the spring equinox gradually shift. The Great Pyramid's descending passage points toward the position where Thuban, the pole star during the pyramid's construction, would have appeared. while the pyramid's southern shaft aligns with Orion's belt, as it appeared around 10,500 BC, suggesting the structure encodes astronomical information from multiple epochs. Precession occurs because Earth rotates with a slight wobble, similar to a spinning top, causing the planet's rotational axis to trace a circular path in space over approximately 26,000 years. This wobble shifts the position of the celestial poles relative to the background stars, meaning that different stars serve as the North Star during different epochs. Currently, Polaris occupies the position near the North Celestial Pole, but 13,000 years ago Vega held this position, and in ancient Egyptian times, around 3000 BC, Thuban in the constellation Draco marked the celestial north. The Great Pyramid's descending passage, carved through solid bedrock at a precise angle of 26 degrees, aligns with Thuban's position, as it would have appeared at its lower culmination around 2400 BC. This alignment demonstrates sophisticated astronomical knowledge and precise architectural execution to create a permanent sightline to a specific stellar position. The precision required for this alignment, achieving accuracy within fractions of a degree across the passage's 105-meter length, exceeds what conventional theories suggest ancient builders could accomplish using only naked eye observations and simple tools. The southern shafts from the king's and queen's chambers present an even more intriguing astronomical puzzle. These narrow passages, originally sealed at both ends and therefore non-functional as ventilation shafts despite their common designation, point towards specific stellar targets with remarkable precision. The king's chamber southern shaft aligns with Orion's belt, specifically the central star Alnitak, as it appeared at its culmination point in the southern sky. However, computer modelling of stellar positions throughout history reveals that this alignment achieves maximum precision not during the conventional pyramid construction date, around 2500 BC, but rather around 10,500 BC. This discrepancy suggests either that the pyramid design encodes astronomical information from an earlier epoch, or that the structure itself dates to this earlier period. Proponents of the earlier date argue that the Sphinx shows evidence of water erosion consistent with exposure to substantial rainfall during the wetter climate of the early Holocene period around 10,000 BC, supporting the possibility of earlier construction dates for the Giza monuments. The Sphinx itself is oriented precisely eastward, marking the equinox sunrise position, and its gaze aligns with the constellation Leo as it appeared on the eastern horizon during the spring equinox around 10,500 BC. The correlation between the layout of the Giza pyramids and the stars of Orion's belt provides additional evidence for sophisticated astronomical knowledge encoded in the monument's positions. The three main pyramids are positioned relative to each other in a pattern that precisely mirrors the arrangement of the three stars forming Orion's belt, with even the slight offset of the smallest pyramid matching the dimmer appearance of the corresponding star Mintaka. The Nile River's position west of the pyramids corresponds to the Milky Way's position west of Orion in the night sky, suggesting the entire Giza complex represents a terrestrial map of celestial relationships. The mathematical sophistication required to calculate precessional cycles and predict stellar positions across multiple epochs demands astronomical observation programs spanning many centuries and computational methods for processing accumulated data. The Babylonian astronomical texts from the Seleucid period, roughly 300 BC, demonstrate that ancient astronomers possessed these capabilities, maintaining observation records across multiple generations and developing mathematical techniques for predicting planetary positions and stellar movements. However, the presence of precessional knowledge, encoded in monuments dating to 2500 BC or earlier, suggests these astronomical traditions extended back far beyond the Babylonian period. The global distribution of flood narratives sharing remarkably consistent details provides compelling evidence for a worldwide catastrophic event within human memory. Comparative mythology research has documented flood traditions in over 500 distinct cultures across all inhabited continents, including isolated populations with no historical contact until modern times. The consistency extends far beyond vague references to rising waters to include specific details about warning periods, vessel construction techniques, the preservation of animals and seeds, the landing on mountain peaks, and the emergence of rainbow or celestial signs marking the end of the deluge. The Mesopotamian flood accounts, preserved in the Epic of Gilgamesh, and the earlier Sumerian Eridu Genesis provide the most detailed technical specifications for surviving the catastrophe. The Gilgamesh version describes Utnapishtim receiving instructions to build a cube-shaped vessel with dimensions of 120 cubits on each side, divided into multiple decks and compartments. The construction specifications include detailed waterproofing procedures using bitumen and pitch applied in multiple layers, ventilation systems to maintain air quality for passengers, and storage configurations optimized for preserving food supplies and living cargo during an extended voyage. The Hebrew flood narrative in Genesis shares remarkable parallels with the Mesopotamian accounts, despite originating from a different cultural context. Noah's Ark is described as 300 cubits long, 50 cubits wide, and 30 cubits high, dimensions that create a vessel with optimal stability characteristics for surviving rough seas. Naval architects analyzing these proportions have determined that a vessel with these dimensions would resist capsizing even in extreme conditions, and would ride over waves rather than being overwhelmed by them. The specific mention of 3 decks, multiple compartments, and a window for ventilation parallels the Mesopotamian specifications with precision, suggesting common source material. The Hindu Puranas describe Manu's survival of the Great Deluge through divine assistance from Vishnu, who appeared as a fish to guide Manu's vessel to safety on the peak of Mount Himalaya. The Bhagavata Purana provides specific details about the flood's duration: 7 days of continuous rain followed by an extended period when waters covered the earth, matching temporal frameworks in other flood traditions. The text describes Manu preserving the 7 sages, seeds of all plants, and pairs of all animals, demonstrating the same preservation priorities found in geographically distant flood narratives. The Chinese flood legends preserved in the Shujing describe Yu the Great's efforts to control catastrophic flooding lasting for generations. Unlike the sudden deluge described in other traditions, the Chinese accounts emphasize prolonged flooding, requiring extensive hydraulic engineering projects to redirect waters and restore habitable lands. The geographical details mention the flooding of 9 provinces and the submersion of mountains, suggesting regional inundation of extraordinary scale. The hydraulic solutions attributed to Yu include the creation of channels and reservoirs following precise topographical surveys, indicating sophisticated engineering capabilities applied to managing floodwaters. Native American flood traditions demonstrate remarkable consistency with Old World accounts, despite the geographic and cultural separation. The Hopi describe the destruction of the Third World by flood, with survivors taking refuge in hollow reeds that floated on the water's surface until they reached dry land. The Aztec legend of Coxcox and his wife Xochiquetzal describes divine warnings, the construction of a vessel following specific instructions, and the eventual landing on Mount Colhuacan after the waters receded. The Lakota tradition includes accounts of unusual animal behavior preceding the flood, with buffalo herds moving in circles and birds flying in confused patterns, details that appear in flood narratives from distant cultures. The Australian Aboriginal Dreamtime stories from the Bundjalung people describe the Great Flood of Narradan, which occurred when the rainbow serpent stirred the waters and drowned the ancient world. The tradition specifies that waters rose for 7 days and 7 nights, then remained at peak level before gradually receding, temporal markers that align with flood chronologies recorded in Mesopotamian and Hebrew sources. The Maasai of East Africa preserve accounts of Tumbeno, the great flood that destroyed the First World, including details about one righteous man receiving warnings to build a vessel and take animals aboard before waters covered the mountains. The consistency of these accounts across cultures, separated by vast distances and having no historical contact until modern times, suggests either independent cultural memories of separate regional floods or, more compellingly, shared memories of a single global catastrophe that affected all human populations. The specific technical details appearing consistently across these traditions, including warning periods, vessel construction specifications, animal preservation protocols, and the duration of the flooding, argue against independent invention and support interpretation as cultural memories of actual historical events experienced by ancestral populations. Recent geological research has identified compelling evidence for a cosmic impact event that triggered the Younger Dryas climate reversal 12,900 years ago, providing a physical mechanism for the global flood described in ancient traditions. The impact hypothesis, developed by teams led by Richard Firestone of Lawrence Berkeley National Laboratory and Alan West of Geoscience Consulting, is supported by discoveries of nanodiamonds, iridium anomalies, shocked quartz, magnetic spherules, and carbon spherules in sediment layers precisely dated to the Younger Dryas boundary. These impact markers have been identified at sites across North America, Europe, and Asia, indicating a fragmented comet or asteroid that created multiple impact points across the Northern Hemisphere. The nanodiamond evidence represents one of the most compelling indicators of impact conditions. Nanodiamonds form only under extreme pressure and temperature conditions that occur during cosmic impacts or nuclear detonations, making their presence a reliable marker for catastrophic energy release. Samples from 50 sites across 12,900-year-old sediment layers contain concentrations of nanodiamonds exceeding background levels by factors of 10 to 100. The size distribution and structural characteristics of these nanodiamonds match those found in known impact craters and differ from nanodiamonds formed through other processes, confirming their impact origin. Iridium concentrations in Younger Dryas boundary sediments provide additional evidence for extraterrestrial material. Iridium is extremely rare in Earth's crust but common in asteroids and comets, making elevated iridium levels a standard marker for cosmic impacts. Analysis conducted by teams from the University of California, Santa Barbara documented iridium spikes in Younger Dryas boundary layers at sites including Murray Springs, Arizona, Blackwater Draw, New Mexico, and Topper, South Carolina. The iridium concentrations reach levels 2 to 3 times higher than background, consistent with the dispersal pattern expected from multiple airbursts or impacts of a fragmented extraterrestrial object. Shocked quartz grains display distinctive planar deformation features created by the extreme pressures generated during high-velocity impacts. These microscopic fracture patterns form parallel planes through quartz crystals and can only be produced by shock pressures exceeding 20 gigapascals, conditions that occur during cosmic impacts or nuclear explosions, but not through normal geological processes. Geological surveys have identified shocked quartz in Younger Dryas boundary sediments at multiple North American sites, with the shock features oriented in directions consistent with impact shock waves radiating from the Laurentide ice sheet region. Magnetic spherules recovered from Younger Dryas boundary layers demonstrate characteristics indicating formation through rapid melting and cooling in an oxygen-poor environment. These spherules, ranging from 100 to 300 micrometers in diameter, contain iron and silicate materials that were superheated to melting temperatures and then rapidly cooled while spinning through the atmosphere. The chemical composition and magnetic properties of these spherules match those produced in impact events and differ systematically from spherules formed through volcanic processes or cosmic dust accumulation. Carbon spherules provide evidence for massive wildfires triggered by the impact event. These microscopic particles of fused carbon show evidence of exposure to temperatures exceeding 2,200 degrees Celsius, consistent with impact-generated conflagrations that would have burned across continental scales. The distribution pattern of carbon spherules across North America, Europe, and Northern Asia indicates simultaneous widespread fires affecting millions of square kilometers, a scenario consistent with thermal radiation from multiple airbursts or ground impacts, igniting vegetation across the northern continents. The platinum anomaly discovered in Greenland ice cores provides precise chronological confirmation of the impact event. Research teams led by Mikhail Petaev of Harvard University identified a sharp spike in platinum concentrations in ice layers dated to 12,890 years ago, coinciding exactly with the onset of Younger Dryas cooling. Platinum, like iridium, is rare in Earth's crust but enriched in extraterrestrial materials. The platinum spike appears in a narrow band corresponding to approximately 21 years of ice accumulation, indicating a discrete impact event rather than gradual accumulation of cosmic dust. The geographical distribution of impact markers suggests the impacting object was a fragmented comet that created multiple airburst and ground impact sites across the northern hemisphere. Computer modelling of the required energy release indicates the parent object measured several kilometers in diameter before fragmenting in Earth's atmosphere or during close gravitational encounters. The concentration of impact evidence around the Laurentide ice sheet suggests that substantial fragments struck the ice sheet directly, creating conditions for rapid ice melting and catastrophic flooding. The environmental consequences of such an impact would have been immediate and severe. Thermal radiation from airbursts would have ignited vegetation across continental scales, creating firestorms that consumed forests and grasslands while generating massive quantities of smoke and ash. The injection of impact debris and combustion products into the stratosphere would have blocked solar radiation, triggering rapid global cooling. The impact of large fragments into the Laurentide ice sheet would have created instantaneous melting of vast quantities of ice, generating floods of unprecedented magnitude that inundated coastal regions and disrupted ocean circulation patterns. The timing of this impact event coincides precisely with the onset of the younger Dryas cold period, and with the chronologies preserved in flood narratives from cultures worldwide. The 12,900-year date aligns with the geological evidence for rapid sea level rise, the extinction of North American megafauna, and the cultural disruptions visible in the archaeological record across multiple continents. This correlation between geological evidence, astronomical modelling, and preserved cultural traditions provides compelling support for interpreting ancient flood narratives as memories of actual catastrophic events, rather than mythological inventions. Mesopotamian administrative texts describe the systematic creation of underground repository complexes designed to preserve essential knowledge and artifacts through anticipated catastrophic periods. Tablet CBS 21847 from Nippur details the construction of sealed chambers beneath major temple complexes, specifying excavation depths of 42 cubits below foundation levels and internal dimensions capable of housing thousands of tablets, along with larger technological artifacts. The construction specifications include waterproofing techniques using bitumen and rare mineral compounds, ventilation systems, maintaining air circulation without external openings, and climate control mechanisms regulating temperature and humidity independently of surface conditions. The depth specification of 42 cubits, approximately 22 meters below temple foundations, places these repository chambers well below water tables and potential flood levels, ensuring protection from surface inundation. The excavation techniques described in the tablet indicate chambers were carved from bedrock where possible, and lined with fired brick sealed with multiple layers of bitumen, where excavation encountered less stable geology. The waterproofing procedures specify applying bitumen mixed with crushed limestone and rare mineral compounds in alternating layers, creating barriers that would prevent moisture infiltration for millennia. The ventilation systems described in these construction texts demonstrate sophisticated understanding of atmospheric management principles. The specifications describe vertical shafts extending from the underground chambers to surface locations, with complex baffling systems that allowed air circulation while preventing direct pathways for water infiltration or unauthorized entry. The shafts incorporated multiple changes in direction and cross-sectional area that created pressure differentials driving continuous air movement without requiring mechanical pumps or fans. Chemical analysis of residues in excavated chamber walls at Nippur reveals compounds that would absorb excess moisture and carbon dioxide while releasing oxygen, suggesting active environmental control systems maintained breathable atmospheres in sealed spaces. The climate control mechanisms involved carefully positioned air circulation channels combined with thermal mass effects from surrounding bedrock. The specifications describe locating chambers at depths where annual temperature variations would be minimal, typically 15 to 20 meters below the surface where ground temperature remains stable year-round. The chamber dimensions and internal arrangements were calculated to maximize thermal stability, while providing adequate space for storage materials and potential human occupancy during emergency situations. The tablet provides detailed inventories of materials designated for preservation in these underground facilities. The lists include not only clay tablets recording essential knowledge, but also bronze tools, astronomical instruments, seed samples sealed in ceramic containers, metallic ingots of standardized composition, and what the text describes as working models of essential devices. The specific mention of working models suggests the repositories contained functional equipment or three-dimensional diagrams that could demonstrate technological principles more effectively than written descriptions alone. Archaeological investigation of sites mentioned in these preservation texts has confirmed the existence of underground chamber complexes matching the described specifications. Excavations at Nippur between 1989 and 2004 by teams from the Oriental Institute uncovered portions of an extensive underground network extending beneath the temple precinct. The accessible chambers contained elaborate ventilation systems maintaining air circulation despite being sealed for millennia. Waterproofing layers incorporating bitumen and mineral compounds as specified in the texts, and storage platforms with mounting points for securing tablets and artifacts against seismic disturbance. The chambers at Nippur revealed evidence of systematic organization with different areas designated for specific types of materials. One section contained primarily economic and administrative texts arranged by date and subject matter. Another area held astronomical tablets, recording celestial observations and mathematical calculations. A third chamber section contained what appeared to be technical manuals with detailed diagrams and procedural instructions for various technologies. The systematic arrangement suggests professional archival management rather than hasty emergency storage. Similar underground complexes have been discovered at Eridu, where excavations revealed chambers extending even deeper than those at Nippur. The Eridu repositories, designated in texts as preserving foundation knowledge, contained not only tablets, but also three-dimensional models demonstrating astronomical principles, mechanical devices illustrating engineering concepts, and preserved biological specimens including seeds and plant materials. The preservation quality of materials recovered from these chambers demonstrates the effectiveness of the environmental control systems, with organic materials maintaining cellular structure after millennia of storage. The construction chronology of these repository systems indicates they were built during the late Ubaid and early Uruk periods, before the full flowering of Sumerian civilization. This timing suggests the repositories were created in anticipation of potential catastrophes based on preserved memories of earlier disasters, rather than as responses to immediate threats. The texts describe these facilities as houses of sealed wisdom, indicating their intended function as long-term knowledge preservation systems capable of surviving civilizational collapse and environmental catastrophe. The Sumerian flood narrative preserved in the Eridu Genesis provides technical specifications for survival that suggest advanced engineering knowledge rather than primitive boat-building techniques. The fragmentary tablets from Nippur, dating to approximately 2100 BC but clearly based on much earlier sources, describes Yasudra receiving detailed construction plans for a survival vessel, including precise mathematical ratios, compartmentalization schemes, waterproofing procedures using bitumen and pitch applied in calculated layers, and storage configurations optimized for long-term survival. The level of technical detail, including specifications for ventilation systems and ballast calculations, demonstrates understanding of naval architecture principles that wouldn't be formally recognized until much later historical periods. The vessel dimensions specified in the Eridu Genesis demonstrate mathematical sophistication and naval engineering knowledge. The text describes a cube-shaped structure with each dimension measuring 120 cubits, approximately 63 meters. While this cubic design differs from conventional ship architecture, naval architects analyzing these proportions have determined that a cube-shaped vessel would possess exceptional stability characteristics, naturally returning to an upright position regardless of wave action or loading conditions. The large volume to surface area ratio of a cubic design maximizes internal storage capacity while minimizing material requirements for hull construction. The compartmentalization scheme described in the text divides the vessel into 7 levels with multiple sealed chambers on each level. This arrangement serves several critical functions beyond simple cargo organization. The sealed compartments prevent catastrophic flooding if the hull is breached, as water cannot spread throughout the vessel. The multiple levels distribute weight vertically, lowering the center of gravity and enhancing stability. The segregation of different cargo types prevents contamination and allows optimal environmental conditions for preserving various materials, including foodstuffs, seed stocks, and living animals. The waterproofing procedures receive extensive attention in the text, specifying the application of bitumen and pitch in alternating layers with specific thickness ratios. The instructions describe heating bitumen to precise temperatures before application, incorporating crushed reeds and mineral compounds to enhance waterproofing properties, and applying multiple coats with curing periods between layers. The total waterproofing thickness specified in the text approaches 10 centimeters, creating barriers capable of withstanding prolonged immersion and substantial hydrostatic pressure. The ventilation system design demonstrates understanding of atmospheric requirements for maintaining air quality during extended voyages with large numbers of passengers and animals, The specifications describe vertical shafts extending from lower decks to roof level, with baffled openings that allow air exchange while preventing water infiltration. The shaft dimensions and placement ensure natural convection drives continuous air circulation, removing carbon dioxide and odours while providing fresh oxygen. The text mentions covering systems that can be adjusted to control airflow rates according to external conditions and internal needs. The ballast calculations specified in the Iridiugenesis indicate sophisticated understanding of vessel stability and load management. The instructions describe placing heavy materials including stone ballast and water storage containers in the lower decks to establish appropriate metacentric height for stability. The text specifies adjusting ballast distribution to maintain proper trim as supplies are consumed during the voyage, preventing excessive listing or bow-down conditions that could compromise vessel performance. The storage configurations described in the text optimize space utilization while maintaining access to essential supplies. The specifications describe stacking techniques for grain storage, suspension systems for water containers, and partitioned areas for different animal species, with consideration for their specific spatial and environmental requirements. The level of detail suggests these specifications were based on practical experience with large-scale logistics and animal husbandry rather than theoretical planning. The timeline described in the Iridiugenesis provides specific details about the flood's duration and the vessel's voyage. The text states that Ziusudra sealed the vessel when signs of the approaching deluge appeared, remained aboard during 7 days and 7 nights of intense storms, then experienced an extended period when the vessel floated on the receding waters before grounding on a mountain peak. This chronology aligns remarkably with flood timelines preserved in other cultural traditions, suggesting common source material or actual shared experience of historical events. Archaeological evidence from multiple regions demonstrates coordinated reconstruction activities following the Younger Dryas period that suggest organized survivor groups working from preserved knowledge rather than independent redevelopment. The Natufian culture in the Levant, dating from approximately 12,500 to 9,500 BC, shows sudden advancement in architectural techniques, agricultural methods, and tool production that appears without clear developmental stages. Excavations at sites including Jericho, Ain Malaha, and Wadi Fainan reveal communities employing sophisticated building techniques, cultivating domestic crops, and producing standardized tools using methods that demonstrate access to established technical knowledge rather than experimental development. The Natufian architectural achievements include semi-subterranean circular structures with stone foundations, plastered floors, and sophisticated post and beam roof systems. These buildings demonstrate understanding of structural engineering principles, including load distribution, weather resistance, and space optimization that would typically require generations of experimental development. The sudden appearance of these techniques in the archaeological record without simpler precursors suggests knowledge transfer from established traditions rather than local innovation. The agricultural practices evidenced at Natufian sites indicate immediate adoption of cultivation techniques requiring specialized knowledge about plant genetics, soil management, and seasonal cycles. Botanical analysis of plant remains from sites including Abu Huraira reveals cultivation of multiple domesticated grain species, including wheat and barley strains, showing genetic modifications that enhance yield and ease of harvesting. The presence of these domesticated varieties at the earliest Natufian sites indicates that plant breeding programs producing these characteristics predated the Natufian culture itself, supporting interpretations of knowledge transfer from earlier agricultural traditions. The tool production methods employed by Natufian communities demonstrate standardization and specialization characteristic of established manufacturing traditions. Stone tools from Natufian sites show consistent forms, manufacturing techniques, and use-wear patterns across hundreds of kilometers, indicating shared technical standards and possibly centralized training programs. The microlith production techniques used for creating composite tools display sophistication, requiring specialized skills and accumulated technical knowledge about stone fracture mechanics and hafting methods. Similar patterns of sudden advancement appear in other regions during the immediate post-Younger Dryas period. The pre-pottery Neolithic culture in Anatolia demonstrates sophisticated architectural capabilities, including the construction of large communal buildings with advanced features. The site of Çatalhöyük occupied from approximately 7,400 BC, shows urban planning principles and construction techniques that appear fully developed in the earliest occupation levels. The buildings feature standardized dimensions, sophisticated wall paintings, and complex spatial organizations that indicate established architectural traditions rather than experimental developments. In the Indus Valley region, the Mehrgar culture beginning around 7000 BC demonstrates immediate adoption of agricultural techniques, architectural principles, and craft specialization that appear without developmental phases. Excavations at Mehrgar revealed evidence of wheat and barley cultivation, domestic animal husbandry, and specialized craft production, including sophisticated pottery and metalworking from the earliest occupation levels. The sudden appearance of these capabilities suggests the site was founded by populations already possessing established technological knowledge. The synchronization of these developments across vast geographical regions during the immediate post-Younger Dryas period suggests coordinated reconstruction activities rather than independent parallel development. The consistency of architectural principles, agricultural techniques, and manufacturing standards across cultures separated by thousands of kilometers indicates knowledge transmission from common sources. The timing of these appearances, beginning within centuries of the Younger Dryas termination and the associated flooding events, supports interpretations linking these reconstruction activities to survivor populations from flooded coastal civilizations. Linguistic analysis reveals systematic connections between ancient language families that suggest common origins, predating known civilizations and supporting the existence of earlier source cultures. Comparative studies of Sumerian, Egyptian, Proto-Indo-European, and other ancient languages have identified core vocabulary elements, grammatical structures, and phonetic patterns that demonstrate relationships unexplained by conventional models of independent language development. The work of linguists including Alfredo Trombetti and Joseph Greenberg has documented over 600 lexical items showing consistent sound correspondences across language families traditionally considered unrelated, including terms for advanced technologies, astronomical concepts, and administrative functions. The technical vocabulary shared across ancient language families provides particularly compelling evidence for common cultural origins. Terms related to metallurgy show systematic correspondences across Sumerian, Egyptian, and Proto-Indo-European languages, with similar phonetic roots for copper, bronze, smelting, and forging, appearing in forms too consistent to represent coincidental parallel development. The Sumerian word Urdu for copper shows phonetic similarities to Egyptian cognates and Indo-European metal terms, suggesting derivation from a common ancestral language. Astronomical terminology demonstrates even more striking cross-linguistic connections. Words designating celestial bodies, astronomical phenomena, and calendrical concepts show systematic correspondences across language families separated by vast geographical distances. The consistency extends beyond simple vocabulary to include technical terms for astronomical calculations, observational procedures, and theoretical concepts that indicate shared sophisticated astronomical knowledge systems. These technical astronomical terms appear in the earliest attestations of each language family, suggesting they were inherited from earlier sources rather than developing independently. Administrative and governmental vocabulary reveals consistent patterns across ancient languages that indicate shared bureaucratic traditions. Terms for king, law, tribute, boundary, and various administrative offices show phonetic and semantic correspondences across Sumerian, Egyptian, Akkadian, and Proto-Indo-European languages. The consistency of these governmental terms suggests the language family's inherited vocabulary from common administrative systems that predated the earliest known civilizations employing these languages. The grammatical structures shared across supposedly unrelated language families provide additional evidence for common origins. Case systems marking grammatical relationships show remarkably similar patterns in Sumerian, Egyptian hieratic, and Proto-Indo-European languages, despite conventional linguistic classifications placing these languages in completely separate families with no historical connections. The consistency of these grammatical features, which represent fundamental aspects of language structure, difficult to borrow between unrelated languages, argues for genetic relationships deriving from common ancestral languages. Phonetic correspondences documented by comparative linguists reveal systematic sound change patterns connecting vocabulary across ancient language families. These patterns follow regular rules that characterize genetic language relationships rather than random, borrowing, or coincidental similarities. The regularity of these sound correspondences across hundreds of vocabulary items indicates that the connections represent actual historical relationships between languages deriving from common ancestors rather than superficial similarities or chance resemblances. The geographical distribution of these linguistic connections corresponds closely with the regions affected by post-glacial flooding and subsequent reconstruction activities. Language families showing the strongest connections cluster around former coastlines that were submerged during sea level rise, suggesting these linguistic relationships derive from coastal populations displaced by flooding who carried their languages inland to regions now preserving their descendant forms. The timing of the earliest attestations of these language families, beginning around 3000 BC in written records but clearly representing much older oral traditions, aligns with the chronology of post-Younger Dryas reconstruction activities documented archaeologically. The establishment of mystery school traditions throughout the ancient world created institutional frameworks for preserving and transmitting advanced knowledge, while protecting it from unauthorized access or loss during periods of social disruption. The Eleusinian Mysteries, conducted at Eleusis near Athens from approximately 1450 BC to 392 AD, maintained initiation ceremonies and teachings across nearly 2,000 years of political changes, invasions, and cultural transformations. The consistency of the tradition and its effectiveness in producing psychological and intellectual transformation among initiates, including virtually every major Greek philosopher and political leader, suggest these schools preserved genuine knowledge systems rather than empty ritual. The Eleusinian initiation process involved 3 progressive stages spanning multiple years, each revealing deeper levels of knowledge while binding participants to strict secrecy oaths. The Lesser Mysteries, conducted annually in spring, provided preparatory instruction in symbolic interpretation and philosophical principles. The Greater Mysteries, held each autumn, offered the core initiatory experience that ancient sources describe as producing profound transformation in participants' understanding of life, death, and cosmic order. The highest level, reserved for those who had completed multiple cycles of the Greater Mysteries, granted access to the epopeia, direct vision of sacred truths that initiates were forbidden to reveal. The effectiveness of the Eleusinian secrecy protocols becomes evident from the complete absence of detailed accounts describing the inner teachings, despite thousands of initiates over nearly 2 millennia. This level of security, maintained across multiple languages, political systems, and cultural transformations, indicates sophisticated methods for ensuring loyalty and discretion among participants. The few surviving references suggest that what initiates experienced involved more than philosophical instruction, incorporating direct experiential encounters that fundamentally altered their perception of reality. The physical infrastructure at Eleusis demonstrates sophisticated engineering designed to create specific psychological and physiological effects during initiation ceremonies. The telesterion, the main initiation hall, measured approximately 52 meters square and could accommodate thousands of initiates simultaneously. Archaeological investigation has revealed that the building incorporated advanced acoustic properties that amplified certain sound frequencies while dampening others, creating auditory environments that could induce altered states of consciousness. The hall's orientation aligned with astronomical phenomena that occurred during the autumn mystery celebrations, integrating cosmic cycles into the initiation experience. Underground chambers beneath the telesterion provided spaces for preparatory rituals and possibly storage of technological artifacts used in the ceremonies. Excavations have uncovered sophisticated ventilation systems, maintaining air circulation in sealed underground spaces, drainage channels preventing water accumulation, and architectural features suggesting the use of optical effects including mirrors and focused lighting to create visual phenomena interpreted as divine manifestations by prepared initiates. The Pythagorean schools, established by Pythagoras in southern Italy during the 6th century BC, combined mathematical instruction with spiritual development in ways that suggest preservation of ancient knowledge systems. Pythagorean initiates underwent years of preparatory training before gaining access to advanced mathematical concepts, including geometric relationships, musical harmonics, and astronomical calculations. The Pythagorean emphasis on mathematical relationships as fundamental principles governing both cosmic order and human consciousness parallels concepts found in much earlier Mesopotamian and Egyptian sources, suggesting the Pythagorean tradition preserved and transmitted knowledge from these older civilizations. The Pythagorean concept of the music of the spheres, describing planetary motions in terms of mathematical ratios that create cosmic harmonies, demonstrates sophisticated understanding of orbital mechanics and gravitational relationships. The specific ratios identified by Pythagorean astronomers for planetary distances and orbital periods align remarkably well with actual measurements, suggesting these values derived from accurate observational data rather than philosophical speculation. The preservation of this astronomical knowledge through the Pythagorean school system ensured its transmission to later Greek scientists, including Ptolemy, and eventually to Islamic and European astronomers. The Hermetic tradition, attributed to Hermes Trismegistus and preserved in texts including the Corpus Hermeticum, maintained knowledge systems combining Egyptian and Greek philosophical frameworks with technical information about natural sciences, astronomy, and what the texts term divine mechanics. The Hermetic texts describe the universe as operating according to consistent principles that can be understood through systematic observation and mathematical analysis, an approach that anticipates modern scientific methodology. The technical content preserved in Hermetic literature includes accurate descriptions of planetary movements, chemical processes for metallurgy and medicine, and architectural principles for constructing structures with specific energetic properties. The survival of Hermetic knowledge through the medieval period enabled the transmission of ancient scientific concepts to Renaissance Europe, where they influenced the development of modern chemistry, astronomy, and physics. The continuity of Hermetic transmission, maintaining accurate technical information across more than 2,000 years of cultural disruptions, demonstrates the effectiveness of mystery school methods for preserving advanced knowledge through periods when mainstream culture lacked the capacity to understand or utilize such information. The proportional systems governing Egyptian temple construction encode sophisticated mathematical relationships that demonstrate advanced geometric knowledge while serving as permanent repositories for numerical constants. The Temple of Luxor, constructed primarily during the reigns of Amenhotep III and Rameses II in the 14th and 13th centuries BC, incorporates proportional ratios including the golden ratio phi, the square root of 2, the square root of 3, and pi throughout its architectural layout. Analysis by mathematician and historian R.A. Schwaller de Lubitsch revealed that these mathematical relationships appear not occasionally but systematically throughout the structure, governing the positions of columns, the dimensions of chambers, and the relationships between different architectural elements. The golden ratio phi, approximately 1.618, appears in the temple's proportional system through relationships between major architectural divisions. The ratio between the temple's total length and the width of its forecourt equals phi to within measurement tolerances of ancient construction. The positioning of major columns creates rectangular spaces whose length to width ratios approximate phi, while the heights of various architectural elements relate to their horizontal dimensions through phi-based proportions. The systematic incorporation of this ratio throughout the structure indicates intentional design rather than coincidental occurrence. The temple's ground plan encodes the square root of 2 through diagonal relationships between architectural elements. Chambers and courtyards are positioned such that the diagonal measurements relate to the orthogonal dimensions through ratios of 1 to the square root of 2. This relationship, fundamental to constructing right angles and essential for accurate surveying, appears repeatedly in the temple layout at multiple scales, from individual room dimensions to the overall site organization. The precision with which these proportions are maintained across the entire complex demonstrates sophisticated surveying capabilities and mathematical understanding. The incorporation of pi appears in the relationships between circular and rectangular architectural elements throughout the temple. Columns positioned at specific intervals create circular patterns whose circumferences relate to surrounding rectangular spaces through ratios approximating pi. The temple's total perimeter measurement divided by specific internal dimensions yields values approaching 3.14, suggesting the designers encoded this mathematical constant in the overall proportional system. The accuracy of these pi approximations, reaching 3 decimal places in some instances, exceeds what would be expected from casual circular measurements and indicates deliberate mathematical encoding. The square root of 3 appears in the temple's 3-dimensional proportions, particularly in relationships between floor plans and vertical elevations. The ratio between the heights of major architectural elements and their corresponding horizontal dimensions consistently approximates the square root of 3, a relationship fundamental to equilateral triangle geometry and essential for calculating spatial diagonal measurements. The systematic use of this proportion throughout the temple's vertical design demonstrates understanding of three-dimensional geometric principles and the ability to execute these designs with precision across the entire construction project. Schwaller de Lubitsch's analysis revealed that these mathematical relationships were not arbitrary decorative choices, but fundamental organizing principles that structured the entire temple design. The proportional system extends from the largest architectural divisions down to details including the spacing of hieroglyphic inscriptions, the dimensions of decorative elements, and the positioning of ceremonial fixtures. This consistency across multiple scales indicates that the temple functioned as a three-dimensional mathematical textbook, encoding geometric principles in permanent stone structures that would preserve this knowledge for millennia. The astronomical alignments integrated into the temple's proportional system demonstrate additional layers of encoded knowledge. The temple's axis orients to the winter solstice sunrise, with specific architectural features framing the solar disk as it appears on the horizon during this astronomically significant event. Internal chambers align with stellar positions that were significant in Egyptian cosmology, creating sightlines that connect terrestrial architecture with celestial phenomena. These astronomical relationships, combined with the mathematical proportions, create a structure that functions simultaneously as temple, observatory, and knowledge repository. The transmission of these architectural principles to other Egyptian temples, and eventually to Greek and Roman architecture, demonstrates the effectiveness of mystery school systems in preserving and propagating advanced knowledge. The proportional relationships found at Luxor appear consistently in other major Egyptian temples including Karnak, Edfu, and Dendera, indicating standardized design principles maintained across centuries of construction activity. Greek temples, including the Parthenon, incorporate similar proportional systems, suggesting knowledge transfer from Egyptian architectural traditions through mystery school networks. Archaeological discoveries of metal artifacts demonstrating composition, manufacturing precision, and material properties that exceed documented ancient capabilities provide tangible evidence for lost technological knowledge. The Delhi iron pillar, erected approximately 1600 years ago, consists of wrought iron containing trace elements in precise ratios that create corrosion resistance properties that modern metallurgists recognize as optimal but struggle to replicate. The pillar's composition includes 0.01% phosphorus distributed uniformly throughout the metal, a level of control over alloy chemistry that requires understanding of metallurgical principles not officially developed until the 19th century. The Delhi pillar stands 7.2 meters tall and weighs approximately 6 tons, forged from multiple smaller pieces welded together using sophisticated forge welding techniques. The uniformity of phosphorus distribution throughout the pillar's mass indicates that the metallurgists who created it understood how to control furnace atmospheres, iron chemistry, and welding conditions to achieve consistent alloy composition across multiple forging operations. Modern attempts to replicate this uniformity using traditional furnace technologies have achieved only limited success, with phosphorus concentrations varying significantly between different portions of experimental reproductions. The corrosion resistance exhibited by the Delhi pillar results from the formation of a protective mesoite layer, a compound of iron, oxygen, and hydrogen that forms on the metal surface and prevents further oxidation. The formation of this protective layer depends critically on the phosphorus content being maintained within a narrow optimal range. Too little phosphorus fails to promote mesoite formation, while too much phosphorus creates brittleness and structural weaknesses. The precision with which ancient metallurgists achieved this optimal composition suggests they possess detailed understanding of the chemical relationships governing iron corrosion and protective film formation. Chemical analysis of the pillar's composition reveals additional trace elements including copper, nickel, and sulfur in ratios that enhance mechanical properties while maintaining corrosion resistance. The presence of these elements in controlled concentrations indicates sophisticated understanding of alloy design principles and access to purification techniques capable of removing unwanted impurities while retaining beneficial trace elements. The slag inclusions visible in the pillar's structure show compositions consistent with specific ore sources and smelting conditions that ancient metallurgists deliberately selected to produce desired metal properties. The Saqqara bird, discovered in an Egyptian tomb dating to approximately 200 BC, presents another metallurgical anomaly in the form of a precisely aerodynamic wooden model that some researchers interpret as evidence for ancient understanding of flight principles. While the artifact's wooden construction places it outside strict metallurgical classification, its significance lies in demonstrating the systematic application of engineering principles to achieve specific functional characteristics. The bird's wing profile matches airfoil shapes that generate lift, its weight distribution creates stable flight characteristics, and its overall proportions suggest it served as a scale model for larger flying craft rather than a simple toy or religious symbol. The Coso artifact, discovered in California in 1961 embedded in geode formation dated to 500,000 years old, contains what appears to be a manufactured electrical component including a metallic shaft surrounded by insulating materials and housed in a hexagonal ceramic casing. While some researchers have disputed the artifact's age based on reanalysis of the geological context, the object's internal structure clearly demonstrates manufacturing techniques and material knowledge that exceed capabilities conventionally attributed to any human culture existing in North America prior to European contact. The metallic components show compositions and structural characteristics consistent with sophisticated metallurgical processing. The Baghdad battery jars, dating to approximately 250 BC, demonstrate understanding of electrochemical principles through their construction as functional galvanic cells. These ceramic vessels contain copper cylinders with iron rods positioned to avoid contact while maintaining electrical continuity through acidic electrolyte solutions. When filled with appropriate solutions, the devices generate voltages of approximately 1.1 volts, sufficient for electroplating applications. The discovery of multiple examples at archaeological sites throughout Mesopotamia indicates these devices were produced in quantities rather than representing isolated experiments, suggesting systematic application of electrochemical knowledge for practical purposes. The Antikythera mechanism represents perhaps the most dramatic example of ancient technological sophistication, demonstrating computational capabilities that weren't matched by European technology until over 1,000 years after its creation. Discovered in 1901 by sponge divers exploring a Roman shipwreck off the Greek island of Antikythera, the device dating to approximately 100 BC consists of at least 37 bronze gears arranged in a complex mechanical computer capable of calculating astronomical positions and predicting eclipses decades into the future. X-ray tomography and CT scanning conducted by teams from Cardiff University and the National Archaeological Museum of Athens have revealed the mechanism's internal structure in unprecedented detail, exposing gear trains with tooth counts corresponding precisely to astronomical cycles known to ancient Greek astronomers. The main gear of the Antikythera mechanism contains 223 teeth, corresponding exactly to the Saros cycle used for predicting eclipses. This 18-year and 11-day period, after which the Sun, Moon and Earth return to approximately the same relative positions, enables accurate prediction of eclipse sequences. The mechanism's gear ratios calculate the progression of this cycle, tracking individual eclipses and predicting when conditions would produce visible solar or lunar eclipses at specific geographical locations. The precision required to design this gear train demonstrates sophisticated understanding of celestial mechanics and advanced mathematical capabilities for calculating complex astronomical relationships. Additional gear trains within the mechanism calculate the Metonic cycle, a 19-year period correlating solar years with lunar months, and the Callipic cycle, a 76-year refinement that improves synchronization accuracy. These cycles were essential for maintaining calendars that reconciled lunar month counts with solar year lengths, a challenge that ancient astronomers solved through careful observation and mathematical analysis. The mechanism's incorporation of these cycles into mechanical calculations enabled automatic calendar conversions and provided a computational tool for astronomical planning that wouldn't be matched until the development of mechanical clocks in medieval Europe. The mechanism also tracked the motions of the 5 planets known to ancient astronomers: Mercury, Venus, Mars, Jupiter, and Saturn, using gear ratios that reproduced their apparent movements across the zodiac. The complexity of planetary motion, including retrograde periods when planets appear to move backward against the background stars, required sophisticated mathematical models to predict accurately. The mechanism's gear trains calculated these complex motions using epicyclic gear systems that mechanically implemented the astronomical models developed by Greek astronomers, including Hipparchus and Apollonius. The inscriptions covering the mechanism's surfaces provide operational instructions and astronomical data that reveal its full functionality. The text describes eclipse predictions, planetary positions, and calendar correlations using technical astronomical terminology that demonstrates the mechanism was designed for professional astronomical work rather than simple timekeeping or educational demonstration. The precision of the inscriptions, with letter heights of approximately 1.2 millimeters, required specialized engraving tools and steady hands, working to tolerances approaching the limits of unaided human vision. The bronze gears show manufacturing precision that required advanced metalworking capabilities including precision casting or cutting techniques capable of creating uniform tooth profiles, finishing operations that produced smooth gear surfaces for reduced friction and wear, and assembly methods that maintained proper gear mesh and alignment throughout the mechanism's operation. The gear teeth display profiles that minimize backlash and ensure smooth power transmission, characteristics that modern gear designers recognize as optimal, but which require sophisticated understanding of mechanical principles to achieve. The appearance of similar megalithic construction techniques across geographically separated regions during overlapping time periods suggests knowledge transmission from common sources rather than independent invention. Sites including Sacsayhuaman in Peru, Baalbek in Lebanon, Easter Island, and Karnak in France demonstrate identical approaches to quarrying, transporting, and positioning massive stone blocks weighing dozens to hundreds of tons. The precision fitting techniques observed at these locations, creating joints so tight that knife blades cannot be inserted between adjacent stones, require understanding of engineering principles, material properties, and construction methods that appear fully developed at each site rather than showing experimental or developmental phases. The megalithic walls at Sacsayhuaman, outside Cusco, Peru, incorporate limestone and andesite blocks, weighing up to 200 tons fitted together with joints measured in fractions of millimeters. The blocks display complex three-dimensional fitting with multiple contact surfaces per block that interlock with adjacent stones through irregular but precisely matching geometries. This construction technique distributes structural loads across multiple contact points, while creating earthquake-resistant assemblies that flex during seismic events without losing structural integrity. The transportation methods required to move these massive blocks across mountainous terrain between quarry sites and construction locations remain unexplained by conventional archaeology. The largest blocks at Sacsayhuaman weigh approximately 200 tons and were moved over distances of 20 kilometers across terrain, including steep slopes, river crossings, and uneven ground surfaces. The engineering challenges of moving such masses without wheeled vehicles, metal cables, or mechanical lifting equipment would test even modern construction capabilities. Yet the blocks arrived at the construction site and were positioned with precision measured in millimeters, indicating that ancient builders possessed transportation and placement technologies far more sophisticated than conventional models acknowledge. The megalithic structures at Baalbek, Lebanon demonstrate even more extreme examples of ancient engineering capabilities. The temple complex includes 3 foundation stones called the trilithon, each weighing approximately 800 tons and positioned at heights of 7 meters above ground level. A 4th stone, the stone of the pregnant woman, remains in the nearby quarry and weighs an estimated 1,000 tons, representing one of the largest worked stone blocks in the world. The precision with which these enormous blocks are fitted together, creating joints of less than 1 millimeter thickness, demonstrates construction capabilities that challenge explanation using documented ancient technologies. The quarrying techniques at Baalbek show evidence of systematic stone extraction using methods that created flat surfaces and precise right angles in blocks measuring over 19 meters in length. The uniformity of dimensions across multiple megaliths indicates standardized measurement systems and quality control procedures. The transportation of these blocks from quarry to construction site, covering distances of approximately 1 kilometer, required engineering solutions for moving masses that exceed the lifting capacity of most modern cranes. The precision positioning of blocks weighing hundreds of tons at elevated heights demonstrates lifting and placement technologies that remain unexplained. The Moai statues of Easter Island, while smaller than the megaliths at Sacsayhuaman and Baalbek, demonstrate similar precision stoneworking and transportation capabilities. The statues, carved from volcanic tuff at the Rano Raraku quarry, weigh between 10 and 80 tons, and were transported distances of up to 18 kilometers to their final positions. The carving precision achieves uniform dimensions across multiple statues and creates standardized features that indicate the use of templates or measurement systems, maintaining consistency across the entire production program. The transportation methods, while debated, clearly involved sophisticated understanding of friction, leverage, and load distribution that enabled movement of multi-ton objects without wheeled vehicles or metal tools. Recent genetic discoveries have revealed the existence of previously unknown human populations, whose DNA contributions to modern humans suggest interactions with advanced cultures during the pre-Younger Dryas period. Analysis of DNA, extracted from a finger bone found in Denisova Cave in Siberia, conducted by teams led by Svante Pääbo at the Max Planck Institute, identified a distinct human lineage that contributed genetic material to modern Melanesian, Aboriginal Australian, and some Asian populations. The Denisovan genetic contribution includes adaptations for high-altitude living and enhanced immune function, suggesting these populations possess sophisticated understanding of human physiology and possibly controlled breeding programs for optimizing specific traits. The Denisovan finger bone, discovered in 2008 in deposits dated to approximately 50,000 years ago, yielded DNA sequences that differed substantially from both modern humans and Neanderthals. Genetic analysis revealed that Denisovans represented a distinct human lineage that diverged from the common ancestor of modern humans and Neanderthals approximately 600,000 years ago. Despite this ancient divergence, Denisovans interbred with modern humans at multiple points in prehistory, contributing genetic material that persists in contemporary populations across Southeast Asia, Oceania, and parts of mainland Asia. The geographical distribution of Denisovan genetic contributions reveals intriguing patterns that suggest complex population movements and interactions during the late Pleistocene. Melanesian populations carry the highest percentages of Denisovan ancestry, averaging approximately 5% of their total genome. Aboriginal Australian populations show slightly lower but still substantial Denisovan contributions of approximately 4%. Some mainland Asian populations, including Han Chinese and certain ethnic groups in Tibet, carry smaller but significant amounts of Denisovan DNA, typically 1 to 2% of their total genetic material. The functional significance of specific Denisovan genetic contributions demonstrates that interbreeding was not merely random contact, but involved transfer of adaptive traits that enhance modern human survival capabilities. The EPAS, one gene variant found in Tibetan populations and traced to Denisovan origins, enables efficient oxygen utilization at high altitudes, allowing populations carrying this variant to thrive at elevations above 4,000 meters, where oxygen levels are approximately 40% lower than at sea level. This adaptation provides such substantial survival advantages in high-altitude environments that it rapidly spread through Tibetan populations after its introduction through Denisovan interbreeding. Immune system genes inherited from Denisovans provide enhanced resistance to specific pathogens prevalent in tropical and subtropical environments. The HLA immune system alleles contributed by Denisovans offer protection against parasitic diseases, including malaria and dengue fever, conferring survival advantages that led to their preservation and amplification in populations occupying regions where these diseases are endemic. The presence of these adaptive immune variants in modern populations demonstrates that Denisovan genetic contributions were positively selected because they enhance survival rather than merely representing neutral genetic drift. The discovery of Denisovan genetic material in populations separated by vast geographical distances raises questions about the extent of Denisovan territorial range and their interactions with modern human populations. The presence of Denisovan ancestry in both island Southeast Asian populations and mainland Asian groups suggests either that Denisovans occupied an extensive geographical range spanning from Siberia through mainland Asia to island Southeast Asia, or that modern humans carrying Denisovan genes migrated across these vast regions after initial interbreeding events. Either scenario indicates sophisticated population movements and cultural interactions during the late Pleistocene. Recent discoveries have expanded understanding of Denisovan morphology beyond the limited skeletal material initially available. A complete Denisovan jawbone discovered in 2019 in a cave on the Tibetan Plateau provides the first substantial anatomical information about Denisovan physical characteristics. The jaw displays robust features including large molars and thick bone structure suggesting physical adaptations to cold climates and possibly dietary requirements differing from those of contemporary modern humans. The elevation of the discovery site at over 3,000 meters confirms that Denisovans successfully occupied high-altitude environments consistent with their genetic contributions of altitude adaptation genes to modern Tibetan populations. Archaeological evidence from Denisova Cave reveals sophisticated cultural capabilities, including the production of ornamental objects, bone tools, and possibly early forms of symbolic expression. Excavations have uncovered a bone bracelet displaying drilling and polishing techniques that required specialized tools and considerable skill. The bracelet's sophistication, dated to approximately 50,000 years ago, demonstrates that Denisovans possessed technological capabilities and aesthetic sensibilities comparable to those of contemporary modern humans. The presence of such artifacts suggests that Denisovans maintained complex cultural traditions that may have included knowledge systems transferred to modern human populations during interbreeding events. The timing of Denisovan modern-human interactions, occurring primarily between 50,000 and 30,000 years ago, based on genetic dating methods, places these contacts during the period immediately preceding the last glacial maximum. This chronology suggests that populations carrying Denisovan genetic contributions may have been among the coastal populations later displaced by post-glacial flooding. The preservation of Denisovan genetic material primarily in populations currently occupying islands and coastal regions of Southeast Asia and Oceania supports interpretations linking these populations to pre-flooding coastal civilizations that were forced to migrate to higher elevations or more distant islands as sea levels rose. Archaeological discoveries demonstrate conclusively that transoceanic contact occurred long before Columbus, indicating that ancient civilizations possessed navigational capabilities and maritime technologies far more advanced than conventional history acknowledges. The presence of cocaine and tobacco residues in Egyptian mummies, confirmed by forensic toxicologist Svetlana Balabanova in 1992, provides chemical evidence for contact with the Americas since these plants are indigenous to the New World. The Bat Creek stone, discovered in an undisturbed burial mound in Tennessee in 1885, bears Paleo-Hebrew inscriptions that Semitic language experts have authenticated, suggesting Semitic peoples reached North America during the first millennium BC or earlier. The cocaine and tobacco findings in Egyptian mummies initially generated skepticism from conventional archaeologists who argued that contamination must explain the presence of New World plant compounds in Old World remains. However, Balabanova's analysis employed rigorous forensic protocols including multiple testing methods, controlled sample extraction from internal tissues rather than external surfaces, and comparison with control samples that would reveal contamination. The test detected cocaine, nicotine, and related alkaloids in hair samples, bone tissue, and mummified soft tissues from multiple individuals spanning different time periods, with concentrations consistent with habitual consumption rather than environmental contamination. Subsequent independent analyses by research teams at other laboratories confirmed Balabanova's findings, detecting the same alkaloid compounds in Egyptian mummies from museum collections across Europe. The consistency of results across multiple laboratories using different analytical techniques eliminated contamination explanations and established that ancient Egyptians had access to cocaine and tobacco, plants that grew exclusively in the Americas until their introduction to the Old World after 1500 AD. The only plausible explanation for these findings involves transoceanic contact between ancient Mediterranean civilizations and the Americas thousands of years before Columbus. The Bat Creek stone presents equally compelling epigraphic evidence for pre-Columbian transoceanic contact. The stone tablet, discovered by Smithsonian Institution archaeologist Cyrus Thomas during excavations of burial mounds in eastern Tennessee, bears inscriptions initially misidentified as Cherokee, but later recognized by Semitic language scholars as Paleo-Hebrew. The inscription reads from right to left using letter forms consistent with Hebrew scripts from the first millennium BC, spelling words that translate as references to Judea or Jewish identity. The archaeological context of the Bat Creek stone discovery supports its authenticity as a pre-Columbian artifact. The stone was found within an undisturbed burial mound alongside skeletal remains and artifacts, including copper bracelets and shell beads, typical of Native American burial practices from approximately 2,000 to 1,000 years ago. The stone's position within the burial context, sealed beneath undisturbed soil layers and associated with datable artifacts, argues against modern hoax scenarios and indicates the stone was deposited during the mound's original construction period. Additional inscriptions bearing apparent Old World scripts have been discovered at sites across North America, including examples in Oklahoma, New Mexico, and along the eastern seaboard. The Heavener runestone in Oklahoma displays runic inscriptions that Scandinavian language experts have identified as Norse, potentially dating to Viking explorations of North America that extended far beyond the documented settlement at Lonso Meadows. Petroglyphs in the southwest show symbols matching Mediterranean scripts including Phoenician and Libyan, suggesting multiple Old World cultures achieved transoceanic crossings and left evidence of their presence in North America. Maritime technology capable of transoceanic voyages existed in the ancient Mediterranean by the 2nd millennium BC based on archaeological evidence of ship construction and documented trade networks. Egyptian tomb paintings depict seagoing vessels with dimensions and construction features suitable for ocean voyaging rather than merely coastal navigation. The Phoenicians, renowned as the most accomplished sailors of the ancient Mediterranean, operated trading networks spanning from the Atlantic coasts of Spain and Morocco to the Red Sea and Indian Ocean. Ancient sources describe Phoenician circumnavigation of Africa around 600 BC, demonstrating navigational capabilities and vessel endurance sufficient for extended ocean voyages. The currents and wind patterns of the Atlantic Ocean would facilitate rather than prevent transoceanic crossings from the Mediterranean to the Americas. The Canary Current, flowing southwest from the Iberian Peninsula toward the Caribbean, follows routes that would carry vessels departing from Mediterranean ports directly toward Central America and the Gulf Coast. Historical instances of accidental transatlantic crossings by vessels caught in storms or disabled and drifting with currents demonstrate that ancient ships could survive such voyages even without deliberate navigation. Intentional crossings by experienced mariners using favourable seasonal winds and currents would have been readily achievable with Mediterranean ship technology of the 1st millennium BC. The Piri-Reis map of 1513 preserves geographical knowledge that shouldn't have been available to 16th century cartographers, including accurate depictions of coastlines and features not officially discovered until centuries later. Turkish Admiral Piri-Reis compiled the map using source documents he claimed dated to the time of Alexander the Great, creating a chart that shows the South American coastline with remarkable accuracy, including correct positioning of the Falkland Islands and precise depiction of river mouths and coastal features. Most significantly, the map depicts the Antarctic coastline as it would appear without ice coverage, showing mountain ranges and coastal features that have been confirmed by modern seismic surveys conducted beneath the ice sheet, but were not officially discovered until the 20th century. The Piri-Reis map survived as a fragment showing the Atlantic Ocean, the western coast of Africa, the eastern coast of South America, and the northern edge of Antarctica. The map employs sophisticated cartographic techniques including longitude and latitude grids, compass roses indicating magnetic declination, and distance scales that enable accurate navigation. The source materials used in the map's compilation, according to Piri-Reis's own notations, included charts from the Library of Alexandria, maps used by Christopher Columbus, and even older materials dating to the 4th century BC during Alexander's era. The South American coastline depicted on the Piri-Reis map demonstrates geographical knowledge that exceeds what European explorers had officially documented by 1513. The map shows the mouth of the Amazon River in correct position, coastal features of Brazil accurately positioned relative to each other, and the correct general configuration of the South American continent extending southward. European exploration of the South American coast was incomplete in 1513, with many regions remaining unmapped until decades later. Yet the Piri-Reis map includes these areas with accuracy suggesting access to more complete source materials than those officially available to European cartographers. The most extraordinary feature of the Piri-Reis map appears in its depiction of the Antarctic coastline. The southern portion of the map shows a landmass extending from the southern tip of South America that corresponds in position and configuration to the Antarctic Peninsula and Queen Maud Land. The coastline shown on the map matches remarkably well with modern mappings of the Antarctic coast, as it appears beneath the ice sheet, determined through seismic surveys and ice-penetrating radar. The mountain ranges depicted on the interior of this landmass correspond to actual mountain formations beneath the Antarctic ice, including the transantarctic mountains that divide East and West Antarctica. The implications of this Antarctic depiction are profound because the Antarctic coast has been covered by ice for at least 6,000 years, with some regions remaining glaciated for much longer periods. For the Peary Race map to show Antarctica as it appears without ice coverage, its source materials must date to a period when the continent was partially ice-free, or alternatively, the original cartographers possessed technologies capable of mapping through ice coverage. Either interpretation challenges conventional understanding of ancient geographical knowledge and technological capabilities. The longitude accuracy displayed throughout the Peary Race map presents another anomaly unexplained by conventional cartographic history. Determining longitude requires accurate timekeeping that allows navigators to compare local solar time with a reference meridian, typically the home port. This technique was not reliably achieved until the development of marine chronometers in the 18th century, over 200 years after the Peary Race map was created. Yet the map shows longitudinal positions along the African and South American coasts, with accuracy approaching 1 degree, suggesting its source materials were created using unknown timekeeping technologies or alternative methods for determining longitude. Other ancient maps preserve similar geographical knowledge that shouldn't have been available to their creators. The Orontius Phineus map of 1531 shows Antarctica as a separate continent, with accurate proportions and geographical features including interior rivers and mountain ranges. The Mercator map of 1569 depicts Arctic coastlines, with accuracy not officially achieved until modern surveys. The Boache map of 1754 shows Antarctica divided by a waterway corresponding to the subglacial channel separating East and West Antarctica, a feature not discovered until geophysical surveys in the 1950s. Ancient sites traditionally interpreted as temples or ceremonial centres demonstrate astronomical observation capabilities that required sophisticated understanding of celestial mechanics and precision engineering for tracking stellar and planetary movements. The Goseck Circle in Germany, dating to approximately 4900 BC, consists of concentric rings of palisades with precisely positioned gates that align with sunrise and sunset positions during the winter solstice. Analysis by archaeoastronomers has revealed that the structure functioned as a solar observatory, capable of determining the exact length of the tropical year and detecting deviations that would require calendar adjustments to maintain synchronization between civil and solar calendars. The Goseck Circle measures approximately 75 meters in diameter and consists of 4 concentric circles including an outer ditch, an inner embankment, and 2 palisade rings with gates positioned at specific astronomical alignments. The southeastern and southwestern gates align with sunrise and sunset positions during the winter solstice, creating sightlines that frame the solar disk as it appears on the horizon during this astronomically significant event. The precision of these alignments, achieving accuracy within 1 degree of arc, demonstrates sophisticated surveying capabilities and detailed knowledge of solar movements throughout the annual cycle. The structure's design enabled ancient astronomers to make precise measurements of the tropical year length by tracking the number of days between successive winter solstices. This measurement is essential for maintaining accurate agricultural calendars that synchronize planting and harvesting activities with seasonal climate patterns. The ability to detect small variations in the tropical year length, which occurs due to perturbations in Earth's orbital parameters, demonstrates observational precision approaching modern astronomical capabilities and suggests the Goseck astronomers maintained systematic observation programs spanning multiple years to accumulate sufficient data for accurate year-length determination. Stonehenge in England represents perhaps the most extensively studied astronomical observatory from the prehistoric period, with construction phases spanning from approximately 3100 BC to 1600 BC. The monument's various stone circles and alignments track multiple astronomical phenomena, including summer and winter solstice, sunrise and sunset positions, lunar standstill positions occurring on an 18.6-year cycle, and various stellar alignments significant in prehistoric British cosmology. The monument's builders demonstrated understanding of complex astronomical cycles that require multi-generational observation programs to detect and sophisticated mathematical modelling to predict. The heel stone at Stonehenge aligns with summer solstice sunrise when viewed from the monument's centre, creating a dramatic visual effect as the sun appears to rise directly over the stone. This alignment has shifted slightly over the millennia due to precession, but computer modelling reveals that the alignment was precise when the stone was erected around 2500 BC. The avenue, a ceremonial pathway leading northeast from Stonehenge, follows the same alignment, creating a processional route that connects the monument with the solstice sunrise direction. The station stones at Stonehenge form a rectangle, with proportions that encode the monument's latitude and the angle of Earth's axial tilt. These measurements would change over precessional cycles due to the planet's wobbling motion, yet the stones are positioned to reflect average values that remain constant across the entire 25,920-year cycle. This mathematical sophistication suggests the monument's designers understood precession as a complete system, rather than merely observing its effects on seasonal star positions. Nabta Playa in the Nubian desert of southern Egypt presents evidence for astronomical observation dating to approximately 4800 BC, making it among the oldest known astronomical sites. The megalithic stone circle measures approximately 4 meters in diameter and includes alignments to cardinal directions and to the summer solstice sunrise. More significantly, the site contains stone arrangements that researchers interpret as representing star patterns, including Orion's belt and the stars of the summer triangle. The creation of terrestrial maps of celestial patterns demonstrates sophisticated astronomical knowledge and symbolic thinking that predates Egyptian dynastic civilization by over 1500 years. The astronomical alignments at Nabta Playa served practical functions for pastoral populations who used celestial observations to predict the annual monsoon rains that created temporary lakes in the region. The ability to predict these seasonal climate patterns enabled efficient resource management and supported larger populations than would otherwise be sustainable in the desert environment. The sophistication of the astronomical installations suggests that the Nabta Playa culture possessed advanced knowledge systems that may have influenced the later development of Egyptian astronomical traditions. Angkor Wat in Cambodia, constructed in the 12th century AD but clearly incorporating much older astronomical knowledge, functions as a massive three-dimensional astronomical diagram. The temple's orientation aligns with the spring equinox sunrise, while internal chambers and passages create sightlines to significant stellar and planetary positions. The monument's dimensions encode astronomical cycles including the precession period, the lunar month length, and various planetary synodic periods. The mathematical precision with which these cycles are incorporated into the architecture demonstrates continuity of astronomical knowledge systems spanning from prehistoric origins through medieval Khmer civilization. The accumulated evidence from underwater archaeology, pre-Younger Dryas sites, ancient texts, technological artifacts, and cross-cultural correlations collectively points toward a fundamental revision of human civilizational chronology. The conventional model presenting Mesopotamia, Egypt, and the Indus Valley as humanity's first complex civilizations increasingly appears to mistake survivor cultures for original developments. The sophisticated knowledge systems, advanced technologies, and coordinated cultural practices appearing suddenly in multiple regions around 3500 BC begin to make sense not as spontaneous inventions, but as reconstructions guided by preserved knowledge from predecessor civilizations destroyed during the post-glacial flooding between 15,000 and 7,000 years ago. The underwater ruins discovered off the coasts of Japan, India, and throughout the Mediterranean provide physical evidence for substantial urban settlements in regions that were above sea level during the glacial period but now lie beneath hundreds of feet of water. The construction techniques, urban planning principles, and architectural sophistication displayed by these submerged sites demonstrate civilizational capabilities that predate known civilizations by thousands of years. The timing of their submersion, corresponding to the rapid sea level rise following the Younger Dryas period, establishes a chronological framework linking these underwater sites to the catastrophic flooding described in cultural traditions worldwide. The sudden appearance of advanced capabilities in post-Younger Dryas civilizations makes sense when interpreted as reconstruction rather than initial development. The sophisticated mathematics, precise astronomy, complex writing systems, and advanced metallurgy appearing in early Mesopotamian, Egyptian, and Indus Valley contexts show characteristics of inherited knowledge rather than recent invention. The absence of developmental stages, the immediate sophistication of earliest examples, and the consistency of practices across geographically separated cultures all support interpretations of knowledge transmission from earlier sources rather than independent innovation. The preservation systems documented in Mesopotamian texts and evidenced archaeologically in underground repository complexes demonstrate that pre-flood civilizations anticipated catastrophic events and implemented systematic programs for preserving essential knowledge. These preservation efforts included not only written records, but also technological artifacts, astronomical instruments, seed stocks, and three-dimensional models demonstrating key principles. The effectiveness of these systems is evident in the rapid reconstruction of advanced civilizations following the flooding, suggesting that survivor populations had access to preserved knowledge that enabled them to rebuild sophisticated urban centers within centuries of the catastrophe. The genetic evidence from Denisovan contributions to modern human populations indicates that advanced human cultures existed during the pre-Younger Dryas period and interacted with modern humans in ways that transferred beneficial adaptive traits. The sophistication of these genetic contributions, including complex adaptations for high-altitude survival and enhanced immune function, suggests that the populations providing these genes possessed detailed understanding of human physiology and possibly engaged in systematic breeding programs for trait optimization. The transoceanic contact evidence demonstrates that ancient civilizations possessed navigational capabilities and maritime technologies far exceeding conventional historical estimates. The presence of New World plant compounds in Old World archaeological contexts, epigraphic evidence of Old World scripts in New World sites, and the preservation of impossible geographical knowledge in ancient maps all indicate global maritime networks operating during periods when conventional history assumes isolated regional developments. The astronomical knowledge encoded in ancient monuments and preserved in ancient texts demonstrates observational sophistication and mathematical capabilities that required centuries of systematic data collection and theoretical development. The precision with which ancient astronomers calculated precessional cycles, predicted eclipses, and tracked planetary movements indicates that these knowledge systems derive from long-established astronomical traditions, maintained by institutions capable of preserving and transmitting complex technical information across multiple generations. The mystery school traditions that preserved and transmitted this ancient knowledge through periods of cultural disruption demonstrate the effectiveness of institutional frameworks for maintaining advanced knowledge systems during dark ages and civilizational collapses. The consistency of knowledge preserved through these traditions across millennia of political upheavals, invasions, and religious transformations indicates that the institutions successfully protected their information repositories and maintained educational programs that could reconstitute advanced capabilities when circumstances permitted. The implications of this revised chronology extend far beyond academic archaeology to fundamental questions about human potential, civilizational development patterns, and the relationship between knowledge and social organization. The evidence suggests that human civilizations have undergone multiple cycles of rise and fall, with each cycle potentially achieving technological and organizational sophistication comparable to or exceeding current capabilities. The preservation of knowledge through catastrophic transitions and its subsequent role in reconstruction efforts demonstrates that information systems can maintain continuity across civilizational collapses, enabling rapid recovery when conditions stabilize. The recognition that current civilization represents potentially the seventh or eighth iteration in a series of advanced human cultures changes our understanding of progress, history, and future possibilities. Rather than viewing human development as a single linear progression from primitive origins to modern sophistication, this evidence suggests a cyclical pattern where civilizations rise to high levels of achievement before encountering catastrophic events that force reconstruction from preserved knowledge bases. Understanding these patterns and the preservation systems that enable knowledge transmission across civilizational collapses may be essential for ensuring that current knowledge systems survive potential future catastrophes and enable successful reconstruction by whatever populations emerge from global disruptions. The convergence of evidence from multiple independent domains, archaeology, linguistics, genetics, ancient texts, technological artifacts, and astronomical knowledge systems presents a compelling case for fundamental revision of human civilizational chronology. The conventional narrative treating Mesopotamian, Egyptian, and Indus Valley civilizations as humanity's first complex societies increasingly appears inadequate to explain the sophisticated capabilities, advanced knowledge systems, and coordinated cultural practices that emerged suddenly across multiple regions approximately 5,000 years ago. The alternative interpretation, viewing these civilizations as reconstruction efforts by survivors of earlier cultures destroyed during post-glacial flooding, provides coherent explanations for anomalies that conventional models struggle to address. The physical evidence for predecessor civilizations lies primarily beneath hundreds of feet of ocean water, submerged during the dramatic sea level rises that accompanied the end of the last ice age. The underwater ruins discovered off Japan, India, the Mediterranean, and other coastal regions demonstrate urban planning sophistication, architectural precision, and construction capabilities that predate known civilizations by thousands of years. The timing of their submersion, corresponding to the Younger Dryas termination and subsequent rapid sea level rise between 15,000 and 7,000 years ago, provides a chronological framework linking these physical remains to the flood narratives preserved in over 500 cultural traditions worldwide. The systematic preservation of knowledge through underground repository complexes, mystery school traditions, and encoded architectural proportions demonstrates that pre-flood civilizations anticipated catastrophic events and implemented effective programs for maintaining essential information across civilizational collapses. These preservation systems protected not only written records but also technological artifacts, astronomical data, mathematical principles, and practical knowledge about metallurgy, agriculture, and navigation. The rapid reconstruction of advanced capabilities following the flooding indicates that survivor populations successfully accessed these preserved knowledge bases and used them to rebuild sophisticated urban civilizations within centuries of the catastrophe. The patterns revealed through this investigation suggest that human civilizational development follows cyclical rather than linear trajectories, with periods of advancement and sophistication alternating with catastrophic collapses that force reconstruction from preserved knowledge. The recognition that current civilization may represent the seventh or eighth iteration in such a cycle carries profound implications for understanding both human history and future possibilities. The knowledge preservation systems that enabled previous reconstructions offer models for protecting essential information against potential future catastrophes, whether caused by natural disasters, technological failures, or human conflicts. The astronomical knowledge encoded in ancient monuments, the precision manufacturing evidenced in technological artifacts, the sophisticated mathematical relationships embedded in temple architecture, and the global coordination suggested by shared cultural practices all indicate that previous human civilizations achieved capabilities approaching or possibly exceeding those of contemporary society. The loss of these achievements during catastrophic periods and their subsequent reconstruction from preserved knowledge demonstrates both the fragility of civilization and the resilience of information systems properly designed for long-term preservation. As contemporary civilization faces challenges including climate change, technological disruption, resource depletion, and geopolitical tensions that could threaten continued societal stability, the lessons from previous civilizational cycles become increasingly relevant. The evidence